Hello students, I am Ashish De and my subject is digital communication. Okay, so in my earlier class I have discussed about compounding. Okay, compounding is basically non-uniform quantization, right? Now today the topic is delta modulation. We have observed in PCM that it transmits all the bits which are used to code a sample. Hence, signaling rate and transmission channel bandwidth are quite large in PCM. To overcome this problem, delta modulation is used. So, these are the needs of delta modulation. Now, delta modulation transmits only one bit per sample. Here, the present sample value is compared with the previous sample value and this result whether the amplitude is increased or decreased is transmitted. In input signal, xt is approximated to step signal by the delta modulator. This step size is kept fixed. The difference between the input signal xt and staircase approximated is confined to levels. One is plus delta, that is step size, and another is minus delta. Okay, so we know delta is step size in the process of quantization. Now, if the difference between these two step size is positive, then approximated signal is increased by one step, that is delta. If the difference is negative, then approximated signal is reduced by delta. Okay. When the step is reduced, 0 is transmitted. If the step is increased, 1 is transmitted. Hence, for each sample, only one binary bit is transmitted. Now, binary bit that is transmitted is basically represented by BNTS. So, B is a function of NTS. TS is sampling time or sampling interval, right? Equal to plus delta, then a binary 1 is transmitted. Binary 1 is transmitted. If this bit has the value of delta, then a binary 0 is transmitted. Okay, so what is TS? TS is sampling interval, and what is N? That is discrete time index, as we know. Okay, now transmitter part for delta modulation. So transmitter of delta modulation. The block diagram for the transmission part of delta modulation consisting of a summer. Here is 1 bit quantizer, now this is the output, output consisting of another summer. There is a delay unit. Delay time is TS. Okay, so one sampling interval delay, right? So this is plus this is obviously a summer. Here is the output of delta modulation. Okay, here is sampled input. There is a negative feedback here. Okay, and here it generates error signal. So error is E of NTS, error signal. Okay, so this is negative feedback. Now this portion basically known as accumulator. Accumulator section. Okay, now this accumulator is so this and this is U of NTS. The output of this summer is basically U of NTS, and this is U of N minus 1 into TS, this thing. Okay. So this block diagram actually generates the delta modulation output. Okay, now the receiver part of delta modulator. So this is basically transmitter part. Now the receiver part, receiver of delta modulation. Now receiver part of delta modulation consisting of this accumulator. So it consisting of a summer. Here is the input. Okay, and here is a delay unit. Delay time is TS, right? Now it for so this is the accumulator section. This is basically the accumulator section. Accumulator, right? And followed by it consisting of a low pass filter. So there is a LPF, okay, which generates output of demodulated signal. Okay. So output is basically demodulated signal. Demodulated signal. Okay, now here is the input and this is positive feedback. Okay, so this is the receiver portion of delta modulation. Okay, now what are the advantages of delta modulation or salient features of delta modulation? The delta modulation has certain advantages over PCM. Since the delta modulation transmits only one bit for one sample, therefore the signaling rate and transmission channel bandwidth is quite small for delta modulation compared to PCM. The transmitter and receiver implementation is very much simple for delta modulation. There is no analog to digital converter required in delta modulation. Now, what are the drawbacks of delta modulation? The delta modulation has two major drawbacks: slope overload distortion, another one is granular or radial noise. Disadvantages. Now, what is bit rate? Signaling rate for delta modulation. So, bit rate of delta modulation. Bit rate R is defined as number of bit transmitted per second. Number of bit transmitted per second. Okay, so that is equal fs into 1, that is fs. Okay, number of bit transmitted per second, that is equal to fs. Okay. This is basically bit rate for delta modulation.